So this one is June 2022, Unit 2. We'll do the MCQs. The reason why I'm revising the MCQs first, so you will have a better understanding of the topics. And for a structure question, after finishing the MCQs, we'll move to structure question. Like we'll do structure questions from the past papers. Which equation represent the standard enthalpy change of a formation? For a formation, the standard enthalpy change from element, we should get 1 mole of a compound. So 1 mole of a compound, here 2 moles. So either A can be an answer or B can be an answer because 1 mole of a compound. And from element, it should be formed. Here, what happened? Oxygen is atom. Like it should be how the element exists, their natural state. That's how it should be formed. So that's why in A, oxygen is a molecule. Oxygen exists as a molecule. So element in their standard state will form a 1 mole of a compound. We call that as standard enthalpy change of formation. How does an oxidizing agent change during a redox reaction? Oxidizing agent itself, it is reduced, and reduction means it will gain electron. So it will gain electron, and what happened to the oxidation number? Because if something is reduced, the oxidation number will decrease. So it will gain electron and oxidation, because reduction means like gaining electron or oxidation number should decrease. That's why A is the right answer. Which of these compound could be expected to have the highest boiling point? The boiling point, first thing, it depends on the intermolecular force. So OH and OH, you can see they will have a hydrogen. They will have dipole, induced dipole force, or London dispersion forces are always there because of the electron. But then we check any other major force, so hydrogen bond is there. Another thing, the boiling point depends on the chain length. Longer the chain, or straight chain will have a high boiling point as compared to the branch, because straight chain will have a large surface area. So this structure shows that this will be a branch like this. But for A, 1, 2, 3, 4 are there, so it will be CH3, CH2, 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 and OH. So that's why B is the right answer. What is the name of a compound with the formula KClO? So potassium, basically you have to work out the valency of a chlorine in KClO2. Each oxygen is -2, so 2 will be -4. Potassium is group 1 plus 1, so the total compound is neutral, so chlorine should be +3. So this should be potassium chlorate 3. The oxidation number of a chlorine is +3 in this compound. Small pieces of calcium are added to a beaker. So whenever a metal is added to water, it will form a metal hydroxide plus hydrogen. So calcium as a metal reacted with water from calcium hydroxide. So this is forming calcium, and this is even the correct. This is calcium hydroxide is written, but the formula is incorrect. So calcium react with water gives calcium hydroxide plus hydrogen. But if it was a magnesium, because it does not react readily, so it will form magnesium oxide plus hydrogen. Which element is oxidized and which is reduced when calcium react with water? So we have this equation. So we have calcium is reacting with water, H2O, and it is forming calcium hydroxide plus hydrogen. So element state oxidation number is 0. When it will form a compound, so calcium will be +2. So it means for calcium, the element oxidized is calcium. And each hydrogen, 2 hydrogen are +2. So each hydrogen is +1. So +1 and here 0. +1 turned to 0, so hydrogen is reduced. That's why A will be the right answer. You can also understand in terms of oxygen, like oxygen is removed from the hydrogen, so that's why hydrogen can also be reduced. We can say it is reduced. What is ionic equation for a reaction of solid barium carbonate with hydrochloric acid? So a barium carbonate react with hydrochloric acid to form barium chloride, most BaCl2 plus carbon dioxide plus water. The state symbol, this is solid, aqueous, most chlorides are soluble, so aqueous, gas, liquid. We cancel out the common ion, so chloride ion is common. So it will be BaCO3, barium carbonate, react with two hydrogen ions, give barium ion, carbon dioxide, and water. So with reference to that, A should be the right answer. Why I did not dissociate the carbonate into ion? Because they mentioned it's a solid barium carbonate and most carbonates are insoluble. So it will remain solid. It won't dissolve. The presence of ammonium ion in a compound can be shown by adding a reagent and warming the mixture and test the gas evolve. So which reagent we add when we add sodium hydroxide? This is a test for the ions. So we add sodium hydroxide, and if so, whenever ammonium compounds are heated in the presence of alkali, it gives off ammonia gas, and ammonia gas turns the red litmus blue. So a compound which is added is sodium hydroxide, and it will turn the red litmus paper blue. Aqueous chlorine is added to an aqueous solution of potassium iodide. So potassium iodide is Ki. What is the color of this aqueous salts of group 1? They are all colorless. So this will be colorless. We add a chlorine, which is aqueous dissolved. It will form potassium chloride plus iodine. This will be aqueous and this is also aqueous. So this is colorless. So the final color is due, what color is seen in, and then what will happen, like it will form iodine. That is first thing. Then a non-polar organic solvent is added. So what will happen? Iodine is more soluble in organic solvents. And the color of the iodine in aqueous, like example in water, it is brown or yellow. But in organic solvent, when we dissolve this, it will be violet. A low concentration is there, purple or a violet, you can mention. Brown is there when it is dissolved in aqueous. But when it is dissolved in organic layer, like organic layer is there, it's not green, it's not orange, it is brown or orange is acceptable in aqueous. But because it's an organic layer, so it is violet or purple. So you have to learn the color of iodine. Iodine as a solid is black or purple. When it is dissolved in water, it is yellow, low concentration, and high concentration, brown or orange. And in organic solvent, it is pink or violet. Titration was carried out. Dilute sulfuric acid was added from the burette. So the final color is due to acid. And sodium carbonate is in a conical flask. So alkaline solution is there in the conical flask. And we add which methyl orange is added. So first, the color of the methyl orange, as the original solution is alkaline solution, so it will be yellow originally. When we add an acid, all the alkali will be used up. When the solution will become neutral, it will be orange in color. And when excess of acid is added, then it will turn red. So in acidic, it is red. In alkaline, it is yellow. And in neutral, it is orange. Again, you have to learn the color changes for the indicators. A student carried out the titrations and did not notice that there was air bubble between the tap and the tip. And during the titration, air bubble filled the acid. The student then carried out two accurate titrations. no air bubble in the burette and no other error. Which of these results could be the three titers of the student? Like first one, there was an air bubble, and the next two, there is no air bubble. So when there was an air bubble, then what should happen? The student should have a large, because when air bubble is there in the burette, so large volume should reduction happen, because this air bubble is taking space, and then we are reacting. And the other two titers were accurate. So when they're so first thing, the first titer is with air bubble. So the first titer with the air bubble, that should have a higher value than the remaining two. So if we check this first titer, these are same, so it cannot be A. When we check the first titer, this is 22.6. So this B can, but this is 22.35, but the other one is high. So both should be less than. This is 22.8, 22.35, 22.4. And this is 22. So means as you can see here, this is 22.8, higher values are there. So because when the air bubble, then it should be higher. When there's no air bubble, the volume removed from the burette should be smaller. That's why C is the right answer. Is it clear? That's when student did the experiment, there was an air bubble initially. So he will get a large reduction in the volume from the burette. But when there was no air bubble, then accurate volume will be measured. Why not B? If you see B, that is 22.65. The first value is smaller, but when he repeat the experiment, the second value is higher. Both values should be smaller because the first experiment was done with air bubble, but the remaining two are done without air bubble. So without air bubble, the volume of the titer which we need should be smaller than the first value with the air bubble. That's why B is not an answer. Then 25 cm cube of 0.1 mole per dm cube sodium hydroxide. The mean titer was 18.7. What is the concentration? So we have the volume and we have the concentration. So first we'll find the moles of sodium hydroxide. Concentration into volume will give us the moles of sodium hydroxide. Concentration is 0.1 and the volume is 25 divided by 1000. So 0.0025. And then use the ratio between sodium hydroxide and sulfuric acid. The ratio is 2:1. So if it is 0.0025, so this will be X. So this should be half of it, 0.00125. That will be the moles of sulfuric acid. And the volume is there. Concentration we can work out. So because we need the concentration of sulfuric acid. So we have the concentration in volume of aqueous sodium hydroxide. And then we got the moles, and from the moles now we get the concentration. So moles divided by volume will give us the concentration. So 0.00125 and the volume is 18 cm cube divided by 1000. So it will be 0.018770. So when you divide, this will give us 0.06. So B will be the right answer. Hydrogen peroxide decomposes as shown. A catalyst increases the rate of reaction of decomposition. So how the catalyst will do? Catalyst will decrease the activation energy, the lower the activation energy. So the same reaction can proceed with a low energy required to start up the reaction. A bottle of a hydrogen peroxide is labeled as 10 volume. This means that 1 cm cube of a hydrogen peroxide solution decomposed to produce 10 cm cube of oxygen. 1 cm cube, sorry, produces 10 cm cube of oxygen. What is the concentration of 10 volume hydrogen peroxide in mole per dm cube? So how to work out the concentration? To work out the concentration is moles divided by volume. The volume is 1. This is we have. And it decomposed to produce 10 cm cube of oxygen. So first we'll work out the moles of oxygen. The oxygen is a gas, so how to work out the moles? But the volume should be in dm cube. So moles of oxygen is volume divided by 24. So volume of oxygen gas is 10 cm cube. So 10 divided by 1000, so 0.01 divided by 24. This will give us the moles. So 0.01 divided by 24, what's the answer? The moles of oxygen. 0.01 divided by 24. Which is 0.00041. Okay. So this will give us 0.00041. So we got 0.00041. So this will be x. Cross multiply. So 0.00082. That will be the moles of hydrogen peroxide. Sorry, the volume was given in cm. Yeah. And 0.00. So this we get 0.00082 moles divided by the volume. What about the volume of hydrogen peroxide? 1 cm cube divided by 1000, so 0.001. So what's the final answer? So it will be D, 0.83, right? Is it clear? So first, from the volume of oxygen, we got the moles of oxygen, and from moles of oxygen, we got the moles of hydrogen peroxide, and we have the moles of hydrogen peroxide and volume, so we get the concentration. A mixture of a hydrogen and iodine is left in a sealed container at 300 until equilibrium is established. The equilibrium mixture is then cooled and the color of a mixture darkened. So what is correct? Like, first thing, you have to understand which position it will, because iodine is there, the colored substance is iodine here. So if the solution is getting darker when we cool down, where the balance has shifted, it means the balance has shifted towards the left hand side. And if we decrease the temperature and equilibrium shift toward left hand side, so what is the forward reaction? The forward reaction is endothermic, because in endothermic reaction, if we increase the temperature, equilibrium will shift towards right or forward, and if we decrease the temperature, equilibrium will shift towards left. So as the color get darker when we cool down, it means equilibrium has shifted toward left hand side. So equilibrium shifted toward left, and the forward enthalpy change for a forward reaction, that will be endothermic, because in endothermic reaction, decreasing temperature only shifted equilibrium towards left. If we increase temperature, it will shift towards the right hand side. What type of reagent will attack on? So nucleophile will attack, because nucleophile means like nucleus loving site. So it will be nucleophile will attack on the positive center. And this, if it was a negative, then it will be electrophile. Which of these alcohols will produce a carboxylic acid when heated? So this is primary alcohol. Primary alcohol will produce carboxylic acid. This is also a primary alcohol because the carbon attached to OH is having only one carbon chain. This one is secondary alcohol. It will produce the ketone, like basically because like primary alcohol first oxidize to aldehyde and then to carboxylic, but secondary ketone, and this won't oxidize at all. So this will not oxidize. So P and Q will oxidize and it will form the carboxylic acid. Two reactions of a cyclohexanol are shown. Which reagent for R1? So here we are converting alkene, like alkene into alcohol. So if I want to convert, the opposite arrow is there. We are converting alcohol, the cyclic alcohol into alkene. So we want to remove the water molecule or we want to reduce like a elimination reaction. So elimination reaction, we use a phosphoric acid. So if you want to convert the alcohol into alkene, we use phosphoric acid. That's why C is the right answer. And here we are converting, in reaction 2, we are converting alcohol into ketone. So we need an oxidizing agent. In that case, we need an acidified potassium manganate 7. So reaction 2 is acidified potassium dichromate or is also an oxidizing agent. Which equation best represent this? So oxidize, there is a difference. Oxidizing agent take part in a reaction. Catalyst does not take part in the reaction. An oxidizing agent provide an oxygen, and how we represent that oxygen which is provided or produced within the reaction, we represent by this. So oxidizing agent provide the oxygen needed for this oxidation to happen. That's why C is the right answer. This is also known as a nascent oxygen, the oxygen which is just produced for a reaction. We call that as a nascent oxygen. So potassium dichromate, potassium manganate provide this nascent oxygen for reaction or oxidation to happen or occur. Cyclohexanol and cyclohexene each has a peak in their infrared spectrum, is not present for other compound. Which are these peaks? So peaks are only there for cyclohexanol. This is actually related to the range. So if we have a cyclohexene, like cyclohexanol and hexene, each has a peak in their infrared spectrum which is not present in other compounds. So what we have to check, here the peak between the other because this is carbon-carbon double bond is there. This will have CO peak will be there and C double bonded with O. These are the two peaks, or OH peak will be there or CO peaks. So you have to use the OH and the CO peaks, the bond rate, the absorption is there. This will have OH peak will be there, and this will have C double bonded with C peak will be there. Peak only in cyclohexanol, and the peak which is present in cyclohexene. So this is due to the presence of a double bond, and this is due to presence of the OH. That's why C will be the right answer. For these type of questions, if the data booklet will be there, or they might give you the information about the bond absorption and all. Because without that, you're not supposed to memorize these numbers. As you can see here, you must have a scientific calculator data booklet. So the data booklet will be there, and using a data booklet, you will work out the absorptions.